Today I'm going to share a research that you might heard before, maybe 1 month ago, maybe yesterday, right? Okay. Whew. Okay, the title of the research is Short-Term Changes in Seafloor Character Due to Flood-Derived in Hyperpycnal Discharge, Typhoon Mindulle, in Taiwan at July 2004. And here's an interesting thing I want to share with you that one of the author, his son is Gao Rexuan. I just noticed that yesterday. Okay. And before I get into the research, I want to test my fluency of the words precipitation and precipitation. Okay, I'm going to go through a small challenge. Uh, precipitation, 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 precipitation. Okay, okay, I now got confused for with these words. Okay, here we go. What's the research mainly about when the typhoon attacks on the Taiwan, and it will cause a lot of rainfall in the mountain, and the rainfall which causes a lot of water down to the river, so that river can carry a lot of sediments to the sea. And after the sediments arrive at the sea, the research wants to know where do they go. So the first thing they wants to know the properties of sediments in the river, and the next thing they want to know the sediment transportation when they arrive at the sea. So there, I have to introduce our two friends. One is Typhoon Mindulle. It is formed at 24th of June in the middle of the Pacific Ocean and arrived at Taiwan at the second day of the July. Disappear on the next 2 days around Korea. And if you see this chart, focusing on the mountain area of the Taichung, you can see there's a high lot of precipitation happens here. So a lot of river waters occurs. So we think that the sediments carried by the water is very obvious and a huge amount. And our next friend is Zhuoshui River. Everybody knows that it's the longest river in the Taiwan, and the length goes to 186.6 kilometers, which has a width 2 kilometers. Watershed area comes to almost 1/10 of the Taiwan's area, and the average of discharge amount is 122.4 cubic meter per second. And okay, I have to introduce these terms again. Hyperpycnal, you can tear it apart, call it hyper and pycnal. And hyper means the over, means the beyond, means the number is greater, and pycnal means is another term of density. So if we combine with each other, it's called it hyperpycnal, it means the greater density. And this video shows that if we pour water that is full of sediments and down in the water tank, the sediments will stays at the bottom of the water and then transport to the left side. So it can stimulate like the sediments transport by the river and arrive at the sea. And we want to define what is hyperpycnal. Hyperpycnal, if the I grab a liters of river waters and I found it that is 40 grams of sediments containing it, and I'll call it hyperpycnal. And so it can allow river water to sink beneath ambient ocean water into which it is discharged. And why Taiwan is a great place to make a research about hyperpycnal events, because we have severe weather conditions, and during 1979 to 1998, 11 Taiwanese rivers experienced at least 100 hyperpycnal events. And because the hyperpycnal events happens in a short time, so not all of the events can be recorded. So the actual number of the events almost certainly is far greater than this number. And before the Typhoon Mindulle arrived at Taiwan, there's another two severe typhoon and also attacked the Taiwan, which is Hebo and Tauraji. Okay, and it also discharged a great amount of sediment. And the first thing is we just mentioned before that we have to know the properties of sediments in the river. So the researchers goes to the Zhuoshui River and he found a bridge on the river. and he just use a rope and tied with a water bottle and collect the river water and then pull up to the bridge. And it collected every 3 hours from 1st of July 6 o'clock into 4th of July, and the period of collecting time is 69 hours, and it got 23 samples. And here's the result of the samples that he collected. If we see these two charts, this one is for precipitation, 2 hours. This one is for discharge, 2 hours. Discharge means the amount of the river per second. Okay, so you can find that there both of them has two peaks and at the same hour. So it shows that high precipitation causes the high discharge. It is easy to understand when the rainfall becomes strong, the water in the river will become more and more. Okay. On the right hand side, this two chart shows the suspended sediment. It means the weight of sediments per liter of river, 2 hours, and the suspended load. It means the weight of sediment transport by the river per hour. So both of them shows three peak and at the same time. So it must have some relationship with it. So we can see that with the high suspended sediment, suspend low is also the greater. So what's the relationship between them? You can see, you can think that if I grab a water, like in this time, I grab a liter of waters and they have 200 grams of sediments, and the suspend low is the actual amount of sediments. So it's the one is for the like a percentage, and the other is for the actual number, the actual weight. And if we use the same y-axis, suspend sediment, and different x-axis is for discharge. Okay, discharge and the hour. You can see that during the typhoon attack Taiwan, this first peak happens in here. And before the typhoon has arrived, it still have some rainfall because of the weather condition. It still has some a little peak, but it is not obvious than the first peak. So you can see that the period that typhoon attack Taiwan has caused a lot of suspended sediment. Okay, we can make a small conclusion of this experiment that before typhoon arrived in Taiwan, the spring of 2004 had been relatively dry, and it was discharging only 20 grams per liters of sediment. And the high concentration, the research says that it might be from the 1999 earthquake, because the uh, huge, huge landslide, and it has a lot of debris happens here. So they all washed away in this time when the typhoon attacks Taiwan. And the total sediment discharge during the 4 days they calculated is 72 million tons, and which 35% to 40% of which was sand. And the other thing, they wants to know where do sediments go when they're arriving at the sea. So they use uh, RVOR2, and they plan two crews before and the after the typhoon, and use the button to scan the seafloor character, and using box core to scratch the sediment stays on the seafloor. And the result of this button shows that after the typhoon, there's a small layer of mud stays on the seafloor. So they can know that after the typhoon, the river does transport the sediments to the sea, and it won't be moved in the short days because the cruise is about 5 days after the typhoon. And the other thing, they just to analyze when they scratch the samples from the seafloor. They just analyze the sand and mud, their percentage. So you can see before the typhoon has come, all of the area mostly is composed by the high percentage of sand. But after the typhoon comes, the area near the river mouth, the percentage of sand is decreasing sharply, minus 91%, minus 96, minus 95. So we can know that during typhoon time, the water transport a lot of mud and it covers the original percentage of sand. But the nature has its own ability to recover its own status. So after typhoon leaving Taiwan for a month, they did another cruise saying that wow, the percentage of sand is increasing now. So they think that they may be the sediments transported by the sea uh, maybe transport by other factors. Uh, so we have to make a conclusion of two experiments saying that during Typhoon Mindulle time, the Georgia rivers discharged 72 million tons of sediment to the coastal waters, and the radar and the sonar shows that there's no seafloor erosion. So there's a small layer stay on the seafloor, and the station U, this one, from 6% to 45% of percentage of sand suggests that some of the Georgia load was initially deposited near the rim-mouth, here to here. And whereas the absence of sand, 1% to 7%, the sediments may be transported by the northward current because of the summertime. There's a current going up. Okay, this is my presentation. Thanks for your listening.
I think your presentation is interesting and your talk is good. He explained the data well by enlarging the axis label, and he also explained the axis and legend before he talked about what is the meaning of the figures.
He did a good interaction with the public at the beginning. He removes the bad information and he explains with different words the same thing, which makes understanding the presentation. And he changed the order of the slide who was not correct.